Hey guys, we're going to look at how to write quadratics in vertex form. So the first thing I want you to do is recall that f of x equals a times x minus h squared plus k is the vertex form of a quadratic function. Okay, that's something that you will need to know. Generally, the way that we've been seeing them recently is written in standard form, but this is vertex form, and that the vertex from this function is h and k. So we're going to look at, given a standard form quadratic, how we can transfer it into this form, and we're going to do that by completing the square. Okay, so here's our first example. This is write f of x equals x squared plus 12x plus 3 in vertex form, and then identify the vertex. We're going to have 3 examples, and they're all going to have the same instructions. It'll just be a different function. So we're going to do this again by completing the square. So what we want to do is isolate the x squared and the x terms, but we're not going to move the 3. We're just going to group them differently. So we'll have f of x equals x squared plus 12x, and I'm going to group these, and I'm going to move the 3 kind of outside of the grouping there. And again, by completing the square, we're going to take the value of b, which in this case is 12, divide it by 2, and square it, and that's what we're going to put as our perfect square there. So again, this is 12 divided by 2, which is 6 squared is 36. So if I add 36 here, what's different about vertex form from normal completing a square? Generally, if we add on one side, I'll add on the other. However, with these being on the same side of the equation, if I add 36 on this side, I actually have to subtract that value, because adding 36 and subtracting 36 are canceling out the terms. Okay, so when you do that, you'll have x plus 6 squared, and then 3 minus 36 is going to be negative 33. Okay, so our new function is f of x is equal to x plus 6 squared and then minus 33. That would be the vertex form of this quadratic in standard form, and then the actual vertex would be negative 6 and negative 33. Okay, so that's again the vertex. So vertex form, vertex. Okay, so that's example 1. Example 2 is a little bit different because there's going to be an actual value for a instead of it being 1. Again, here, there's a 1 right here, which is nice. That's what you want it to be. This one, however, has a 3 in front of it, so it does make the problem just slightly different in how you operate. Same idea. You're going to group these two terms together and kind of move the 7 separately. So I'm going to look at it as f of x is equal to 3x squared minus 18x, and then kind of move the plus 7 over here. However, we need this a value to just be 1. So between the 3 and the 18, I'm going to factor out a 3. If you were solving, you would divide it completely, including the 7, but we don't have to worry about that on this problem. We kind of move the 7 over. So this would now become x squared minus 6x plus something, and then plus 7. And remember, if I add it here, I have to subtract it on this side, different from solving. Okay, so instead of taking 18 dividing by 2 and squaring it, we're going to take 6 divided by 2 and square it. So when you take negative 6 divided by 2 squared, it's going to end up being negative 3, but when you square it, it becomes positive. So we get positive 9 there. Now, you got to be careful that when you actually, the number that you're going to put on this slot here is really going to be whatever you factored out times that value. So this case is going to be 3 times 9, which is 27. Okay, so you do have to be careful about that. And we'll go ahead and factor this. It has now become 3 times x minus 3 squared, because that's what x squared minus 6x plus 9 is factored to. And then we have this positive 7 minus 27 is going to be negative 20. So this becomes the vertex form of the quadratic 3 times x minus 3 squared minus 20, and your actual vertex would be 3 coming from this value right here and negative 20. Okay, the last example is going to also include a value in front here of the x squared. However, it's going to be negative, so it does perform just slightly different from this. All right, so this is again, right, f of x equals negative 2x squared plus 8x minus 12 in vertex form, and then identify the vertex. Okay, so again, essentially the same thing. We're going to group just these two values and kind of ignore the 12. So we got f of x here And I'm going to do this kind of right now. So on the last one, we factored out a 3, but I actually want to factor out not just 2, but negative 2, because you most times want to have the x squared be a positive value. So the negative in this case just tells you that it is a reflection. It would open down in terms of the parabola if you were graphing, but we want to factor out a negative 2. Now when you do that, factoring out a negative 2 from a positive 8 is going to give you negative 4. So we have now x squared minus 4x. Okay, so it was positive up here, but you factor out a negative 2, so it becomes negative. Bring down our minus 12 over there. And now the value here, take negative 4 divided by 2, would be 2 squared would be positive 4. And the value that you are going to subtract on this side is now a negative 8, because it's negative 2 times 4. Now subtracting a negative 8 really means negative 12 plus 8. Okay, negative 12 plus 8. All right, so if you factor, here we still got our negative 2. This is now going to become x minus 2 squared, and this over here is going to become minus 4. All right, so our vertex form is f of x is equal to negative 2 times x minus 2 squared, and then minus 4, and then the actual vertex is 2, negative 4.